When I was a kid, I was really keen on finding out how things around me work. One of my favorite things to do was to put my hand out of the window of my dad's car and observe how the air was flowing depending on how I moved my hand. One day, my dad told me that if I tilt my hand upwards, my hand will start going up, and that is how airplanes fly. This made me really keen on learning how airplanes work, how they fly, and how they move from place to place. Some years later, in elementary school, I really liked learning more things about planets, and especially the one we live in, Earth. When I first learned in first grade that the Earth rotates around its axis, by combining my knowledge on the things I loved the most, a question came in my mind. Does the spin of the Earth affect flights? Let me explain what I mean. Let's suppose that an airplane travels 8 hours from a point A to a point B. Within 8 hours, however, the Earth is spinning. Does this affect the duration of the trip? For example, when the plane flies in an opposite to Earth's spin can reach its destination earlier, while when it flies in the same direction the Earth spins, it takes more time. After some research, I found the answer and it is no. And the reason is the same for which when we jump, the ground is not lost under our feet. Or when you throw a ball upwards, ends up again in your hands and not half a kilometer away. Thus, it is important to understand that there is no absolute movement. All motions are relevant. We cannot say that something is moving or not moving if we do not define that the object moves in relevance with what. The Earth revolves around its axis from the west to the east, once a day. It is difficult to quantify this rotation because we do not observe it in our everyday life. For example, think about being on a ship traveling at a steady speed in a calm sea. Many times, if you do not look out, you cannot understand whether you are moving or not. In our view, a stationary reference system and a system that moves at constant speed in a straight line are equivalent. Together with the Earth, however, everything is rotating. Not just the objects stuck to its surface, such as stones, trees, and us, but also everything raised above the surface of the Earth, such as air and airplanes. Because airplanes are not designed to fly while being stationary, let's imagine a helicopter parked on the ground and let's say that the Earth is spinning at 1000 kilometers per hour. The helicopter obviously follows Earth's motion because otherwise it would not stay in the place. Its speed with respect to Earth and a stationary observer is zero. Its velocity with respect to the Earth's axis and a stationary observer outside Earth is 1000 kilometers per hour to the east. Now let the helicopter begin moving eastwards at 200 kilometers per hour. This velocity is measured with respect to the observer on Earth. As for the space observer, the helicopter is moving at 1000 plus 200 equals 1200 kilometers per hour. It is moving eastwards at a higher speed than Earth is moving east. If the helicopter flies westwards at 200 kilometers per hour, for the observer in Earth, only the direction of the movement is changed. For our space observer, the helicopter continues to move towards the east, but at a speed of 1000 minus 200 equals 800 kilometers per hour. Due to the fact that the helicopter is now slower than the speed Earth rotates, the helicopter appears to be moving westwards. A helicopter, or any flying vehicle, cannot observe the Earth spinning beneath it because Earth does not rotate in relation to it. Earth rotates in relation to its axis with all other objects that are connected to Earth. But how does a vehicle not longer parked on the ground follow the motion of the Earth? The answer is Newton's first law. A body remains stationary or continues to move in a straight line at steady speed until some external force affects it. When the helicopter takes off, its speed towards the east remains as is because there is no force to affect its movement. The helicopter gains altitude by pushing the air down, so the forces that affect it are the resistance of the air that pushes it upwards and its own weight pulling it down. If these forces are equal, the helicopter remains stationary. There is no force in the horizontal direction that would make it move for the observer on Earth or stop moving for the observer in space.
Created using Powtoon.